Climate change or climate crisis, global warming facts of life. Contemporary concerns regarding rising temperatures caused by increases in atmospheric carbon dioxide levels due to the burning of fossil fuels and widespread agriculture practices, anthropogenic sources of greenhouse gases, and the accompanying sea level rise when taken together called the climate crisis. Ignore the big picture and overemphasize the carbon dioxide versus temperature relationship as the primary climate driver. In reality, the primary climate driver is Earth's orbit around the Sun, and the real concern should focus on the prospect of long-term cooling. Earth's climate is affected by several natural phenomena that interact with each other over very long periods of time spanning tens, hundreds, thousands, even millions of years.
These phenomena are variations in Earth's orbit around the Sun, changes in Earth's atmosphere, fluctuations in ocean currents, positions of the continents, volcanism, variation in Sun's energy output, impact events. Regarding temperature, Earth's temperature has varied widely over the past 550 million years, and at present its temperature is primarily controlled by variations in Earth's orbit around the Sun. Earth is currently in a geologic ice age, which is loosely defined as when one or both poles are covered by ice sheets. Ice ages are characterized by many long cycles of extensive cooling with multiple advance and retreat of glaciers. Glaciations interspersed with short periods of warmer temperatures, interglacials. The current ice age began 33 million years ago with the formation of the Antarctic ice cap. This event was precipitated by plate tectonic changes which caused the opening of the Drake Passage and the Tasmanian Seaway and the creation of the Antarctic Circumpolar Current. These events drastically cooled the Antarctic continent, which then cooled temperatures over the rest of the Earth. The current ice age intensified 2.8 million years ago with the formation of the Greenland ice cap. This event was precipitated by plate tectonic changes, which caused the closing of the Isthmus of Panama and the creation of the Gulf Stream. These events cut off the flow of warm Pacific water into the North Atlantic, drastically cooling the northern hemisphere. For the past 1 million years, Earth has experienced at least 8 warm and cold cycles averaging every 100,000 years. These are called Milankovic cycles. These cycles are caused by variations in the shape of Earth's orbit, circular versus elliptical, or the orbit's eccentricity. Earth's temperature varied +5 to -8 degrees Fahrenheit from its present value during this period. For the period 1 million years ago to 2.8 million years ago, the of its cycles averaged 41,000 years. These particular cycles were primarily caused by variations in the tilt of Earth's axis of rotation. Earth's temperature swings during this period were between 3 to 5 degrees Fahrenheit. Earth is currently in an interglacial period with a mild stable temperature that has lasted the past 10,000 years. However, the temperature fluctuated about ±3 degrees Fahrenheit at various times over the past 4,500 years. These fluctuation periods span 400 to 1,000 years. Many of these fluctuations were influenced by volcanic eruptions. Earth's current temperature is about the lowest it's been in the past 278 million years when the Earth was experiencing an ice age. Back then, Earth's temperature was lower than present over a period from 278 million years ago to 355 million years ago. Earth's temperature more recently fell below the present about 2.8 million years ago and has mostly stayed that way until the present interglacial period, which started its warming 21,000 years ago and reached its peak warmth 11,000 years ago. During each of the 4 previous interglacial periods, Earth's temperature was higher than present by 2 to 5 degrees Fahrenheit. During each of the 4 previous glacial maximums, Earth's temperature was 8 degrees Fahrenheit colder than present. Regarding atmospheric carbon dioxide. Atmospheric carbon dioxide is primarily driven by Earth's natural carbon cycle. This carbon cycle slowly moves carbon back and forth between the atmosphere, carbon dioxide and methane. Earth's surface, plants, animals, and calcium carbonate rocks. Earth's oceans dissolve carbon dioxide and calcium carbonate in seashells. Earth's interior, organic and organic carbon sequestered in the mantle by plate tectonics. Carbon in the mantle is eventually returned to the atmosphere and surface by plate tectonics in volcanoes. Burning fossil fuels and agriculture practices add additional carbon dioxide to the atmosphere and for progenic sources. Earth's atmospheric carbon dioxide is currently about 410 parts per million. Atmospheric carbon dioxide was much higher in Earth's past. It was about 7,500 parts per million 550 million years ago. 1,000 parts per million 66 million years ago. 500 parts per million 5.5 million years ago. 375 parts per million 1 million years ago. 180 parts per million 20,000 years ago. Atmospheric carbon dioxide has been gradually decreasing, going back billions of years because of an imbalance in Earth's carbon cycle. During the past 800,000 years, atmospheric carbon dioxide has generally fluctuated between 180 parts per million and 280 parts per million in general sync with variations in Earth's temperature. The relationship between temperature and atmospheric carbon dioxide is not fully agreed upon. This is because warm Earth temperatures can raise atmospheric carbon dioxide. Cold Earth temperatures can lower atmospheric carbon dioxide. High atmospheric carbon dioxide can raise Earth's temperature. Low atmospheric carbon dioxide can lower Earth's temperature. Regarding sea level. Sea level is influenced by air temperature, which affects rate of evaporation. Water temperature, which affects its expansion. Ice age glaciations, which affect ice buildup or melting. Plate tectonics, which affect the arrangement of continents. Sea level has varied widely over the past 550 million years. It was about 1,300 feet higher than present 465 million years ago. 1,083 feet higher than present 430 million years ago. At present level 232 million years ago, 885 feet higher than present 75 million years ago. 1,180 feet higher than present 52 million years ago. 80 feet lower than present 1.2 million years ago. 26 feet higher than present 125,000 years ago during the previous interglacial. 394 feet lower than present 20,000 years ago during the last glacial maximum. Sea level was higher than present during 3 out of the 4 previous interglacial periods. Sea level would rise about 25 feet if the Greenland ice sheet melted completely. There is evidence that this has happened at least once within the past 1 million years. More specifically, about 425,000 years ago parts of Greenland were covered by forests. The Greenland ice sheet formed 2.8 million years ago. Sea level would rise about 200 feet if the Antarctic ice sheet melted completely. The current Antarctic ice sheet formed 33 million years ago. Climate change reality. Humans have consumed about 30% of all recoverable fossil fuels so far. If burning of all fossil fuels stopped immediately, Earth would continue to warm regardless. Due to the anthropogenic atmospheric carbon dioxide already in the atmosphere. Accordingly, Earth's temperature will continue to slowly rise over the millennia regardless of what is done to reduce carbon dioxide emissions. This warming would continue for the next 200 to 1,000 years, and the anthropogenic atmospheric carbon dioxide already in the atmosphere will likely postpone the onset of the next glaciation by another 20,000 to 50,000 years. If all remaining recoverable fossil fuels were burned immediately, the next onset of glaciation would likely be postponed by another 500,000 years. Temperature rise will undoubtedly cause sea level to rise above present level. Since the sea level rise cannot realistically be stopped, plans should be made to relocate low-lying populations. More concerning, Earth actually started to enter its next natural cooling cycle about 6,000 years ago due to forcing by Milankovic cycles, but anthropogenic atmospheric carbon dioxide already in the atmosphere has mitigated that trend, prolonging the current interglacial. But eventually, because of Milankovic cycles, Earth will again enter a long period of cooling with extensive glaciations and with devastating consequences for humanity. During the last glacial maximum, about 21,000 years ago, much of the northern hemisphere was covered by ice sheets and glaciers. These ice sheets and glaciers are going to return someday. Serious plans need to be made on where and how to relocate billions of people. Considering that most of Earth's land mass is in the northern hemisphere, how will we grow enough food to continue to feed the Earth's population? And if we reverse the impact of cumulative anthropogenic carbon dioxide emissions, we potentially risk initiating the Earth's entry into the next period of glaciations.